Friction. It's a force that tries to stop things moving around so much, and that's it. Bye. Just kidding. Ha! Just like everything else in physics, it gets a lot more complicated.
It's pretty old and doesn't like change. Kinda like old men. In particular, it kind of hates change in motion and is always trying to stop it. Friction actually comes in a multitude of different forms and is actually a big family of old people. There are many types of friction, such as static friction, sliding, rolling, and fluid friction, and probably many more, but we're going to focus on these basic ones first. Let's meet them.
So your static friction, it acts on things resting on a surface and keeps it from moving until some force comes along and ruins that for it. Imagine a really, really heavy and big piece of furniture, like a large shelf, on a wooden floor. When you are trying to get that shelf to move, you have to exert a force by pushing the shelf forward in the direction that you want it to go in. To overcome the static friction acting on the shelf at rest, you gotta, you gotta push it, obviously. But the thing is, it requires a much greater amount of force than it does overcoming the kinetic friction once you get that shelf moving. So this type of friction in particular, while it is kinetic friction since it's moving, it's also sliding friction, by the way, since you got two things sliding up and against each other. There's also rolling friction, another type of friction, and it's just it's a type of frictional force that acts on a rolling object. Rolling, as in like rotating to convey some kind of movement. Like a ball. You know. And that's just what it is. It's just tries to stop things from moving. It usually accelerates an object by decreasing its speed, having it to come to a stop. And if you know the technical definition of acceleration, then that makes sense to you. And if not, you might want to talk to your 6th grade physics teacher, or your 6th grade science teacher, rather. Last but not least, we have fluid friction, yet another type of kinetic friction. Think of a plane. It's always overcoming fluid friction when it's flying in the air. Now think of the air. It's a fluid. Not like water, but like a gas, That counts as a fluid. If you're not too sure, you might want to go back to chemistry class. We're trying to cover physics here. Now you know the concept of friction. But did you know these concepts can be explained with math? Everybody's favorite subject.
Formulas on friction. Woo! Math is great, and with these formulas, we'll find out how to apply and solve for friction. We all know F equals ma, right? The sum of all forces is equal to mass times acceleration. When friction acts on an object, there is a push and a pull. So we could write an equation like the force of friction always acts to oppose you when you try to move an object. But wait! There's more. How do we find force friction? Well, static friction is created when you push something that is at rest. Since force normal is equal to mass times gravity, our final equation for static friction is... bam! All done. Wait, you say in your head. What about the kinetic friction formulas? As my friend stated earlier, kinetic friction is only used for an object that needs to stay in motion. So we could use the equation, except we need to change the coefficient of friction. And all done. Now that we have some formulas, let's apply them to some totally real-life situations. So suppose you had a huge gold ingot laying around in your house, and the burglar comes to nab that huge fortune. I'm the burglar, by the way. We need to calculate if this thief would even get the gold moving. Theoretically, the static coefficient of friction between the ingot and the ground is 0.3. And the ingot has a mass of 1,000 kilograms. That's quite a lot of moolah you got there. Let's plug these numbers into the static friction equation. That equals 2,940 newtons, which kind of doesn't mean anything to us until it's in pounds. And if we convert that, it equals about 661 pounds. Wow, that's a lot. I can't move that, so I guess I'm not the thief. Anyway, so this super strong thief has started moving the gold bar. Now, the question is, how much force is required to keep it going? Now, for that, we turn to kinetic friction. Say that the ingot, which weighs 1,000 kilograms, has a coefficient of kinetic friction of 0.18. Plug these numbers into the kinetic friction formula. That equals 1,764 newtons, which is about 397 pounds. That's a lot of force to push. So most likely, no thief is going to get away with your gold. And this is great, because you could calculate all this with these friction formulas. Friction is pretty great, isn't it?
Sure is. That's why we made this video. Thanks for watching, everybody.
Hey Maricar, want to know what really grinds my gears?
What?
Friction!
Judy, don't tell any more friction jokes.
Aww.
Because I won't let them slide.